morning students. In the previous class, we say how to solve the practical problem using Gaussian elimination method. Now the same exercise, we do one problem using same Gaussian elimination method. The same exercise, the third one. You see the last in bracket, use Gaussian elimination method to solve the problem by the same method. Okay. The question, an amount of rupees 65,000 is invested in 3 bonds at the rate of 6%, 8% and 9% per annum respectively. So a person have an amount 65,000. He deposited in the bank in 3 bonds. Each bond gives one bond is 6%, second bond is 8%, and the third bond is 9% per annum. In your book, is a printing mistake is a 10% is given, but the correct percentage is 9. So I order the percentage per annum. The total annual income is rupees 4,800. That is the interest amount of all the 3 bond in one year is 4,800. And one more data is given. The income from the third bond. The income from the third bond is rupees 600 more than that from the second bond. Okay, the income from the third bond is more than, how much more than? 600 more than the income from the second bond. It is our given data. Then our question is, determine the price of each bond. So to find the price of each bond, that is rupees 65,000 is split into 3 bonds. 1.6, second bond 8, and the third bond is 9%. Now to find the amount of each bond, so we will take the prices of the bond. Let X, Y and Z be the prices of first, second and third bond respectively. It is the first line. We will take the price of the first bond is X, the price of the second bond is Y, and the price of the third bond is will be taken is Z. But the value of X plus Y plus Z is always 65,000 because the total amount is 65,000. So we will take the first bond price is X, second bond price is Y, and the third bond price is Z. Next, by the given data, we frame it an equation. So we first frame 3 equations. This is the first step in word problem. We form an equation. Okay, what is the first equation? In 3 bonds, how much amount will be invested? The amount is rupees 65,000. So X plus Y plus Z is equal to 65,000. Framing each and every equation is very important. Is the first equation, where X is the price of the first bond, Y is the price of the second bond, Z is the price of the third bond. But the total bond amount, it should be exactly 65,000. I leave the rupee symbol, and lastly we put the rupee symbol. So is the first equation. Over. Next, the rate of interest of the each bond is 6%, 8% and 9%, and whose income value is 4,800. That is the interest amount value is 4,800 for annum. So how to write? Okay, first bond, what is the rate of percentage? 6%. So 6% of X plus. Second bond rate is 8%. So 8% of second bond price is will be take Y plus 9% is a third bond. So 9% of Z. That is X is the price of the first bond, whose 6%. Y is the price of the second bond, whose rate of interest is given is 8%. And the third bond price is Z, whose rate of interest is 9. So sum of all the interest amount it should be given rupees 4,800. So 4,800. So framing this equation is also important. The first one is a total amount, and the second one is whose interest amount. Interest of the first bond, interest of the second bond, interest of the third bond, whose total value is 4,800. How to write 6%? We write 6% as 6 by 100. 6 by 100 into x plus 8%, 8 by 100 into y plus 9%, 9 by 100 into z is equal to 4,800. Now we simplify the equation. We say this 3 number involving 100 denominator. We remove. So the next step, I multiply 100 on both sides. So multiply by 100. Then it becomes this 300, 100 are cancelled. So first one becomes 6x plus 8y plus 9z is equal to, already 4,800 is there. You add 2 zeros because multiply by 100. So it become 4,80,000. So it is the second equation. Now we frame one more equation. First equation is the total amount. Second equation whose interest amount, and one more data is given. What is another data? Another data. So the income from the third bond. Okay, the income from the third bond. What is the rate of interest of a third bond? Is 9%. What is the price of the third bond? Z. So is given also. Nine percentage of Z is nothing but is equal to, okay, the income from the third bond. The third bond income is 9%. The price of the third bond is Z. So 9% of Z is nothing but is equal to 600 is more than using the symbol is a plus. So 600 plus. Given the word is more than, so I will use the symbol is plus. Suppose if it is a less than, I put the symbol is minus. Is more than that from the second bond. What is the rate of interest of the second bond? 8%. What is the price of the second bond? Y. So 8% of Y. The framing, the third equation is also important. That is, the income from the third bond is 600 more than 8% of the second bond. So we write 9% of Z. 9 by 100 into Z is equal to 600 plus 8%. 8 by 100 into Y. So I write it is 9Z by 100. Important, you don't cancel these hundreds. In RHS it contains 2 depths. So we cross multiply and then we cancel 100. So we write it is 9Z by 100. 600 plus 8 by 100. I cross multiply here. 600 into 100 is 60,000 plus 8y whole divided by 100. Okay, I cross multiply. So 100. We cancelling this 100. 9z is equal to 60,000 plus 8y. So we write it is minus 8y plus 9z. The plus 8y becomes that side minus. Minus 8y plus 9z is equal to 60,000. It is the first step, okay, to frame a 3 linear equations. In a word problem is the first step to find the 3 linear equations. It is the first equation, that is total amount, and the second one is whose interest amount. and the third one is given. The income from the third bond is 600 more than the income from the second bond. Now these are the three equations. Now using these three equations to solve the problem by Gaussian elimination method. After finding these three equations, what is the next step? To convert the given system of equation in matrix form. How to write in matrix form? The first one is the value of coefficient of x, y, z, and x, y, z, and RHS is the constant matrix. The constants are 65,000, 4,80,000, and 60,000. The next step is to convert the system of equation in matrix form. So it is a matrix form of the given system. What is the first equation? X plus y plus z is equal to 65,000. Coefficient of x, y, z are 1, 1, 1. And the second equation, 6x plus 8y plus 9z. And the third equation is start from minus 8y. So there is no coefficient of x, so 0, important 0. Minus 8y, so minus 8. Plus 9z plus 9z, whose values. The next step is the augmented matrix. The augmented matrix is, the another name of augmented is extended. A by B. First you write the values of A. The values of A. 1, 1, 1. 6, 8, 9. 0, minus 8, 9. Put one line. The next matrix is B. The value of the B is RHS 65,000. 4,80,000. And the third one is 60,000. The next step, to convert this augmented matrix in echelon form. Echelon form is the first row, first element is always non-zero. It's better to convert in 1, but it already in 1. The next step, to convert at least this triangle shape of element become 0. So you see directly 0 is there. So the next step, to convert that element is also become 0. So we have changes. So in first row there is no change, so we write the first row as it is. 1, 1, 1, 65,000. 1, 1, 1. And we write 65,000. Our motive is to convert that element become 0. We consider R2 and R1. Suppose that element is also become 0, when we separate it become 0. So how to write R2? We write R2 as R2 minus 6 times of R1. So we write R2 as R2 minus 6 times of R1. So 6 minus 6. 6 minus 6 is 0. 8 minus 6. 8 minus 6 is 2. 9 minus 6. This is small number. 9 minus 6. 9 minus 6 is 3. But this is a big number. Is 4,80,000. So we write R2 as R2 minus 6 R1. So R2 value is 4,80,000 minus 6 times of the corresponding element in R1 is 65,000. So minus 6 times of 65,000. Now we find that value is 65,000. Is 4,80,000 minus. We already 3 zeros is there, so we add 3 zeros. 5 6 30, 0 remainder 3. 6 6 36 plus 3 is 39. Is 4,80,000 minus 3,90,000. The answer is 90,000. So big numbers are right. 4,80,000 minus 3,90,000. So the answer is 90,000. Next, don't change the third row because Already the element 0 is there, so don't change the third row. So we write first the third row as it is. So 0 minus 8, 9, 60,000. 0 minus 8, 9, 60,000. What is the next step? To convert this element is also become 0. So now change the first and second rows. 1, 1, 1, 65,000. Second row 0, 2, 3, 90,000. So no changes the first two rows. Third row. Our motive is to convert that element is also become 0. After we change these two elements become 0, we consider only the second row and third row. So you see 2 minus 8. Both are possible in the second table. And also you see the sign are differ. When the sign are differ, just we add, it becomes 0. So how to convert this element becomes 0? You have any idea? We write R3 as R3 plus 4 R2, because 4 2s are 8, plus 8 minus 8 are vanish. So we write R3 as R3 plus 4 times of R2. What is the reason to add plus here? Both are different sign. So these two numbers are 0. We multiply any manner, that becomes 0. R3 plus 4 R2. 4 2s are 8. Plus 8 minus 8 is 0. And that number. R3 is 9. Plus 4 times R3. 4 3s are 12. 9 plus 12. 9 plus 12 is 21. Next. Again a big number. So I write sine row. How to write R3? We write R3 as R3. The value of R3 is 60,000 plus 4 times of R2. 4 times of the value of R2 is 90,000. 60,000 plus 4 into 90,000. Already 4 zeros is the 1, 2, 3, 4. 4 nines are 36. So 3,60,000 plus 60,000. Okay, 3,60,000 plus 60,000. When we add, we get 4,20,000. I add 3,60,000 and 60,000. So I add this 12. Remainder is 1. So 4,20,000. So that value is 4,20,000. You see it is in echelon form. The first row, first element is non-zero, and at least this triangle shape of element is become 0. So it is called an echelon form. So we write it is an echelon form. You remember, after converting echelon form, what is the next step? The next step is, again we write the system of equation in matrix form as given system. We convert the matrix form into the system of equations. Important, we don't see the given question, we see the echelon form of the matrix. The echelon form of the matrix is again converted into the system of equations. These are all coefficients of x, y, z. And RHS is the constant. So how to write the first row? Always the first one is a coefficient of x. Second one coefficient of y. Third one coefficient of z. So how to form the first equation? 1 into x is x, plus 1 into y is y, plus 1 into z is z. So x plus y plus z is equal to 65,000. We put it is equation 1. This is the first equation. And the second equation. First one is a coefficient of x, but it is 0. 0 to x is 0. Second one is the coefficient of y. So 2 into y is 2y. This one is the coefficient of z. 3 into z is 3z. Is equal to 90,000. We are using this equation, so I put it is 1 and 2. Now you see the third one. First one is the coefficient of x. 0 into x is 0. Second one is the coefficient of y is also 0. Third one is the coefficient of z. So 21 into z is 21z. Is equal to the RHS is 4,20,000. So we directly cancel here. So the value of z, 21 2s are 42. Is exactly twice, 2 times, and we have this 4 zeros. So the value of z is 20,000. That means the price of the third bond, z indicates the price of the third bond, is 20,000. Now using the value of z to find the remaining two values. The next step, I use the value of z in either 1 or 2. We substitute 2. So 2 gives 2y plus 3z. The value of z is 20,000. Is equal to 90,000. 2y plus 3 into 20,000 is 60,000. Is equal to 90,000. 2y is equal to 90,000 minus 60,000. That is, plus 60,000 becomes the same minus 60,000. So 2y is equal to 30,000. So the value of y is 30,000 by 2. We cancel, we get the value of y is 15,000. We find the value of y also. Now using the value of z and y in the first equation, okay, we move the first equation. So first equation gives, you see the first equation, x plus y plus z is equal to 65,000. We already find the value of y and z. The value of z is 20,000 and the value of y is 15,000. Now we use these two values in the first equation. So one gives x plus y. The value of y is 15,000 plus z. The value of z, you see the value of z is 20,000. Is equal to, what is the RHS of the first equation? The RHS of the first equation is 65,000. So x plus 15,000 plus 20,000 is 35,000 is equal to 65,000. So x is equal to 65,000 minus 35,000. So the value of x is 30,000. We must write the conclusion. Our given question is not to find the value of x, y, z. To find the price of each bond. We will be taking x is the price of the first bond, y is the price of the second bond, and z is the price of the third bond. Therefore, the prices of first, second and third bond are, okay, the price of the first bond will be taken is x, whose price are 30,000. Now we use the amount symbol, 30,000. The price of the second bond is the value of y. The value of y is 15,000. The value of y is 15,000. So rupees 15,000. And the price of the third bond is z. The value of z is 20,000. Rupees 20,000 respectively. So it is the conclusion of the given sum. So you add the 3 value, we get 65,000. 30,000 plus 20,000, 50,000 plus 15,000. So total invested is 65,000. So the price of the first bond is 30,000. The price of the second bond is 50,000. And the price of the third bond is 20,000. Next, we move the next exercise. The given question will be asked examine whether or test the given system of equation is a consistency or not. By using the rank method, or the word is not given, just examine the consistency. Okay, is a heading. Consistency of linear equations by a rank method. The rank method is suppose is not given. You see the question, the word consistency is involved or not. So what is meant by a consistent? A consistent means it is possible to find the solution of the system of equations. Now you see the previous equations all are called non-homogeneous. So there will be 2 types of equations. So one is non-homogeneous linear equations, and the second one is just a homogeneous linear equation. What is meant by non-homogeneous and homogeneous? Suppose the given system of equation RHS Allah is non-zero or anyone is non-zero is called non-homogeneous. The equation contains all the RHS values are 0, that is all the constant becomes 0, it is called a homogeneous. Now we see all are non-homogeneous. In the last exercise we see some homogeneous also. So I explained what is meant by non-homogeneous and homogeneous. So we see before question is all are non-homogeneous. I give one example. 2x plus 3y plus 3z is equal to 5. Minus x plus y minus z is equal to 0. 2x plus 5y plus 6z is equal to 10. So this system of equation is called non-homogeneous because the RHS is, this 2 element is non-zero. So this system of equation is called non-homogeneous. We see the previous all questions are non-homogeneous. At least suppose that value is also 0. So this is also called non-homogeneous because the first equation is a non-zero element. Suppose this element is also becomes 0. Okay. Now we see all the RHS values are 0 and all the LHS are just coefficient of x, y, z. That is all the constants are 0. Then the name of the equation is called homogeneous. So this is the only difference, non-homogeneous and homogeneous. Now we see all the previous problem involving non-homogeneous because all the sum involving RHS are constants. Now we check it is possible to find the solution or not. It's an easy one. The given system of is the first step. The given system of equation is converted in matrix form. And the next one to check the rank of both the matrices. I'll give one example. Suppose the augmented matrix A by B. The last step I converted in echelon form. 1, 2, 3. Suppose this element is 5. 0, minus 2, 4, 0. 0, 0, 5, 4. Suppose I will take one augmented matrix in echelon form. Now you see it is in echelon form. How to check it is consistent or not? So we find the rank of both the augmented and the rank of individual E. Now you see what is the rank of this matrix? We already see the previous exercise. The rank means the number of non-zero rows. It contains how many number of non-zero rows? 1, 2 and 3. So is the first case. So we write it is row of A by B is equal to 3. Next Just what is the value of a row of A? Row of A means the rank of the matrix A. So in rank of the matrix A, we don't consider the last column because we need only the rank of the LHS, that is a bar LHS, only A. So it is a matrix A value and it is extended B. So row of A by B is 3. What is the row of A? That is rank of A. 1, 2, you don't consider the last column. 1, 0, non-zero row. 2 non-zero row. 3 non-zero row. So both are is equal to 3. It should be is equal to the number of unknown. So row of A by B is equal to row of A. Both are is equal to 3, where 3 is called the number of unknown. What is meant by number of unknowns? The number of unknown means the values of x, y and z. You say suppose I will take on 3 equations. In 3 equations it contains the variables are x, y and z. Both the rank should be is equal to the number of unknown, that is 3. Then the system is consistent and the system has a unique solution. Is the first rule to check both the ranks. Suppose both the ranks are is equal to 3, then the system is consistent, that is it is possible to find the solution, and it has how many solutions? It contains only one solution. This is called the unique solution. This is the previous one. You know very well, when we converted in the system of equation, 5z is equal to 4. So the value of z is 4 by 5. Using the value of z, we find the value of y. Then we substitute these two values, we find the value of x also. It is a previous model. It is the first case. Suppose this element is 0 and that element is also 0. Now what is the rank of A by B and A? What is the rank of A by B augmented matrix? Rank means the number of non-zero row. First row, second row over. You see the third row fully 0. It is a 0 row. So row of A by B is 2. And row of A is also 2. Both the rank should be is equal to 2. So is equal to 2. I say it is the less than the number of unknown. Less than the number of unknown. What is meant by less than? Because x, y, z, suppose 3 variables are given, is 3. 2 is always less than 3. So in this case, how to solve, sir? How to solve? We have 2 equations and 3 unknowns. Suppose we converted it in system of equation. How to write? We write the first one, x plus 2y plus 3z is equal to 5. Okay? X plus 2y plus 3z is equal to 5. Second equation, minus 2y plus 4z is equal to 0. Third equation, we can't frame because all elements are 0. So 0 equal to 0. Now you see how many equations are there? There will be 2 equations. How many unknowns? Unknown means x, y, z. How many unknowns? 3 unknowns. 2 equations and 3 unknowns. We can't solve. If a 3 unknowns is there, we must have 3 equations. So how to solve? So in this case, the given system is consistent and the system has infinitely many solutions. It's not a one solution. It contains many solutions. So we assign one variable as a constant. What are the variables? The unknown. X, y, z are called the variables. So in this case, that is 2 equations and 3 unknowns is there. We assign one variable as a constant. It's your choice. We assign any one variable. Generally, we take it is z, where t is a real number. Z is equal to t, where t belongs to r. So we put any real number. So we treat this variable as a constant. Then we sum. Suppose the solution system is 3t plus 5 minus 2t and the value of t is t, where t is a real number. Suppose I put the value of t is equal to 0. I have one set of solutions. Okay, suppose I put t is equal to 0. Okay, 0, 5, 0, 0. I put and one solution. I put t is equal to 0, 5, 0, 0. This is one solution. Sir, I put t is equal to 1. Yes, t is also 1 is also a real number. We said the another set of real number. Suppose I put t is equal to 1. 3 ones are 3. 3 plus 5, 8. Minus 2 plus 1. Is the second set of solution. This 2 number is only real number. The number of real number is infinite. So we put one value of t, we get one set of solutions. So we put so many values. So the system is consistent and the system has infinitely many solutions. It is the second case. And the third case, suppose this 2 element is also 0. The second row fully 0. Now what is the rank of A by B? Rank of A by B, the number of non-zero rows is just 1. Rank of A is also 1. Both the rank is equal to 1. So row of A by B and row of A should be 1. It should be less than the number of unknown. That is 1 is less than 3. So how to solve? Then it has only one equation and the 3 unknowns. Suppose we convert it in the system of equation. How to write? X plus 2y plus 3z is equal to 5. Second equation fully 0. Third equation fully 0. Now we have how many equation? Only one. And how many unknowns? 1, 2, 3. How to solve? We can't solve directly. So in this case, we assign 2 variables as a constant onto sum. Because it has only one equation and 3 unknowns. So in this case, we assign 2 variables as a constant and we solve the problem. So generally we will take y is equal to s and z is equal to t, where s and t is a real number. Y is equal to s and z is equal to t, where s and t is a real number. So we treat these 2 variables as a constant. Then to substitute here, we get the values of x. But the value of x is also contains in terms of s and t. So we put the different values of s and t, we put the different solution. So in this case also the system is consistent and the system has infinitely many solutions. Is that case? And the final case. One more case is possible. Suppose I will change some elements. 5, 4, 3, 0, 0. That element is minus 1. Now we see what is the rank of A by B. That is A by B. Augmented matrix rank is the number of non-zero row. 1, 2, 3. Minus 1 is there. So it is also non-zero. So row of A by B is 3. What is the rank of A? So we don't consider the last column. So it is the value of the matrix A. What is the rank of A? That is the number of non-zero rows. 1, 2. You see the third row fully 0. So rank of A is 2. So now you see both the ranks are differ. So we say it is row of A by B is not is equal to row of A. Both the ranks are differ. 1 is 3 is not is equal to 2. So in this case, our given system is inconsistent and the system has no solution. That is, there is no solution to find in this system. Both the rank should be equal. It may be 3, 2 or 1. Suppose that ranks are differ, the given system is inconsistent, that is, there is no possible to find the solution. Inconsistent and the system has no solution. It is a working rule or the formula. I told you earlier how to find. So there will be 4 types. Okay, you must memorize this table. Is a formula. The first type, the discussion and solution. Suppose both the rank is equal to 3. We solve 3 equations. So both the rank it should be is equal to 3. 3 is equal to the number of unknowns. The system is consistent and the system has unique solution. Unique means only one. That is, it has a one value of x, one value of y, and one value of z. This is the first case. It is possible both the rank should be exactly 3. And the second case, I reduce the rank 3 to 1 like this. Next, both the rank should be is equal to 2. But 2 is a less than number of the given unknowns. 2 is a less than number of unknown. Then the system is consistent. That is, it is possible to find the solution. But the system has infinitely many solutions. Put z is equal to t, where t belongs to r. So infinitely many solution. What is the reason to write infinitely many solution? Both the rank is equal to 2. So it has 2 equations and 3 unknowns. So we assign one variable as a constant. Put z is equal to t. And the third case, both the rank is equal to 1. A by b and a. Both the is equal to 1. Is also the lesser number of 1 is less than 3. In this case also the system is consistent. In this case the system is consistent. It has infinitely many solutions and we assign or we put y is equal to s and z is equal to t where both are real number. We put any letter. Usually we will take in our textbook s and t is there. So I will take y is equal to s and z is equal to t. But this s and t is a real number. S comma t is real number. What is the reason to assign these 2 variables as a constant? Because it has only one equation and how many unknowns? 3 unknowns. One equation, 3 unknowns we can't solve. So we assign 2 variables as a constant, then we find the solution. So we put the different value of s and t, we get a different value of a solution. So it has infinitely many solutions. And the fourth one, both the ranks are differ. One is 3 and another one is 2. Or one is 2, another one is 1. Both the ranks are differ, then there is no way to find the solution. So in this case we see it is inconsistent and the given system has no solution. So first we must memorize this formula. Okay, it's a formula. Just 4 cases in the exercise. This 4 cases is enough. Both the rank is 3. The system is consistent. The system is unique solution. Second one, both the rank, that is row of a by b and row of a is equal to 2. Then the system is consistent and the system has infinitely many solutions. 2 equations and 3 unknowns. So we assign one variable as a constant. We will be take z is equal to t where t is a real number. This is the second case. Third case, both the rank should be is equal to 1. That is row of a by b and row of a. Both are is equal to 1. Is less than the given number of unknown x, y, z. So in this case also the system is consistent and the system has infinitely many solutions. We assign y is equal to s and z is equal to t, where s and t is a real number. What is the reason to assign these 2 variables as a constant? Because we have only one equation and 3 unknowns. And the final one, fourth one, suppose both the ranks are differ. Row of a by b is not is equal to row of a, then the system is inconsistent and the system has no solution. You see the exercise 1.6, the first one. You see the question. Test for consistency. So test for consistency, and if possible, solve the following system of equations by a rank method. So both method is also given to solve the problem in rank method, and also to check it is consistent or not by using rank method. So given system of equations, there will be 3 equations. Now I say this system of equation is called a non-homogeneous because RHS, all are contains values 2, 7, 4. Now we solve the non-homogeneous equation of system. So to solve the problem by rank method and also to check it is consistent or not. So rank means first step is to write the given system of equation in matrix form. Next we write in augmented form. Then to convert in echelon form. So the matrix form is directly we write the matrix form. The given system of equation in matrix form. So the given system of equation in matrix form. The first equation coefficient of x, y, z 1, minus 1, 2. 1, minus 1, 2. Second equation coefficient of x, y, z 2, 1, 4. 2, 1, 4. Third equation coefficient of x, y, z 4, minus 1, 1. 4 minus 1, 1. Next, x, y, z is equal to the RHS values. The RHS are the first equation 2, second equation is 7, third equation is 4. So the first step to convert the system of equation in matrix form. Now it is of the form. You see it is of the form AX is equal to B. So it is of the form AX is equal to B. What is the next step? We write in augmented matrix. The augmented matrix is that is the extended matrix. A is extended by the matrix B. Now it is a value of the matrix A. This matrix is extended by the another matrix B. So A by B value is 1 minus 1 2. So 1 minus 1 2. It should be extended by B. The value of the B, corresponding value of the B is 2. So 2. Second row 2 1 4 is extended by 7. So 2 1 4 7. 2 1 4. Here we write 7. Third row 4 minus 1 1 4. 4 minus 1 1 4. It is the augmented matrix. After we write the augmented matrix, we do the same work. The next step to find the rank of this augmented matrix. We need a rank of the augmented matrix to convert the matrix in echelon form. The first row, first column element is no problem, is always 1. So it is already 1 is there, so don't change the first row. So we write the first row as it is 1 minus 1 2 and 2. The next step to convert these two elements become 0. 2 is there, so we consider in which rows? R2 and R1. So how to write R2? Our motive is to convert that element becomes 0. Suppose to convert this element is also 2, we separate this 2, we get 0. So we write R2 as R2 minus 2R1. That is, we write fully the R2 second row as second row minus 2 times of the first row. 2 minus 2 was 2. 2 minus 2, 0. Here 1 minus 2 into minus 1. Okay, the R2 value is 1 minus 2 into the corresponding element is also minus 1. 1 minus to minus is plus. 2 ones are 2. So 1 plus 2 is 3. That element. 4 minus 2 times of 2. 4 minus 2 times of 2. 4. 4 minus 4 is 0. That element. We write R2 as R2 minus 2 times of R1. R2 is 7. 7 minus 2 times of the corresponding element of R1 is again 2. 7 minus 2 to 4. 7 minus 4 is 3. So R2 is 1. Next, to convert that element is also become 0. So it is your choice. We consider R3, R2 or R3, R1. Is your choice. We consider anywhere. Now I consider R3 and R1 because I multiply R1 fully by the number 4. So it is your choice, we consider R3 and R2 also. So I consider R3 and R1. So I write R3 as R3 minus 4 times of R1. What is the reason I write to 4? In R1 the number is 4. Suppose the number 1 become 4, 4 minus 4 is 0. So we write R3 as R3 minus 4 R1. 4 minus 4, 0. The another element is also important. How to change the number minus 1? How to write R3? We write R3 as R3. The value of R3 is minus 1. Minus 4 times of. The corresponding element of R1 is again minus 1. So minus 1. Minus to minus is plus. 4 ones are 4. Minus 1 plus 4 is plus 3. Next. The number is R3 1. The corresponding element in R1 is 2. How to write R3? R3 as R3 1 minus 4 times of 1 minus 4 times of 2. 1 minus 4 2s are 8. 1 minus 8 is minus 7. Next. The number 4 become? To identify? The number 4 become. We write R3 as R3 minus 4 R1. So 4 minus 4 times of 2. 4 minus 4 times of 2. 8. 4 minus 8 is minus 4. So this 2 element is also become 0. Over. But it is not in echelon form. To convert in echelon form, that element is also become 0. So the next step. So actually it is a value of the augmented matrix is in equivalent. So the first 2 rows is no change. So we write the first 2 rows as it is. 1 minus 1 2. 2. Second row 0 3 0 3. Our motive is to convert that element become 0. After we converted this 2 element become 0, we consider only R2 and R3. So you see both the numbers are same. So just we separate. So we write R3 as R3 minus R2. We write the third row fully. Third row minus the second row. 0 minus 0, 0. 3 minus 3, 0. Minus 7 minus 0 is minus 7. Minus 4 minus 3. Minus 4 minus 3 is minus 7. Now we see this is, I say this form is called an echelon form. The first element is non-zero. And at least the triangle shape of element become 0. So now we write it is in echelon form. But to solve the problem by a rank method, so next we check the rank. Here, row of A by B. That is the rank of the augmented matrix A by B. What is the rank? Rank means the number of non-zero rows. How many non-zero rows is there? 1, 2, 3. So it has a 3 non-zero row. So row of A by B is equal to 3. Next, we check the rank of A alone. Also, row of A. A means we leave the augmented. So this fully elements is the values of the matrix A. What is the rank of A? So you don't consider the last column. So this is the A matrix. So it has how many non-zero rows? 1, 2, 3. A row contains at least any one of the element, we say it is non-zero. So this also 3. Now we check both the rank first of all is equal, and also the number of unknown. Therefore, row of A by B is equal to row of A is equal to 3, where 3 is the number of unknown. 3 is equal to the number of unknowns. Unknown means X, Y and Z. So I already write the table. Is fall in which type? It falls in the first type. Both the ranks, it should be is equal to 3. Both the ranks are equal, and both the rank is equal to 3 is equal to the number of unknowns. So in this case, the given system is first of all consistent. Therefore, the system is consistent. Important, we must write the consistent, because our question is examine the consistency. The system is consistent, and the system has how many solutions? The system has is the first case, both the rank should be is equal to 3. Therefore, the system has a unique solution. Unique solution means it contains only one solution. Both the ranks is equal to 3, and also is equal to the number of unknown. We must write these two lines, because you see the question. The question is, test the consistency, if it is a consistent or not. So we first write the consistent. So the system is consistent, that is, it is possible to find the solution. The word consistent means it is possible to find the solution. Next one, the system has unique solution. The next step to find is unique solution. The next step to find the solution. The system has a unique solution, we already tell. The next step to find whose unique solution. How to find? Again, the last echelon form is converted into the system of equations, the previous same model. So how to find the solution means to convert this matrix form into the system of equation. So we write, the LHS, that is a line LHS fully is values of coefficients of X, Y and Z, and RHS is the constant value. So first one is indicates a coefficient of X. So 1 into X is X. Second one is a coefficient of Y. Minus 1 into Y is minus Y. Third one is a coefficient of Z. Plus 2 into Z is 2Z is equal to 2. So we write, coefficient of X in the first row is 1. So 1 into X is X. We see the second one, coefficient of Y is minus 1. So minus 1 into Y is minus Y. And next one is a coefficient of Z. So 2 is the coefficient of Z. So 2Z is equal to 2. So plus 2Z is equal to 2. So we use the equation. So I put it is equation 1. Next we see the second row. Okay, what is the second row? 0, 3, 0, 3. First one, coefficient of X is 0. We leave. Second one, coefficient of Y, 3 into Y is 3Y. Third one, coefficient of Z is also 0 here. So 0 is equal to 3. So how to frame the second equation? So just 0 into X. 0 into X plus 3 into Y plus 0 into Z is equal to 3. I write elaborate. So these are cancelled. So 3Y is equal to 3. We directly find here the value of Y is equal to 1. Next, we move the third row. Now we see the third row. It is the third right. First one is a coefficient of X is 0, vanish. Second one is a coefficient of Y is also 0, vanish. Third one is a coefficient of Z. So minus 7 into Z is minus 7Z. RHS is the constant. So minus 7Z is equal to minus 7. So minus 7Z is equal to minus 7. I'll directly cancel this minus 7. So what about Z? the value of z is also 1. Now we find the values of y and z. Now using these two values in the first equation, because we need the another one variable x. So in first equation, x minus y, minus the value y is 1, minus 1 plus 2z, 2 of z. The value of z is also 1. RHS is 2. X minus 1 plus 2 is equal to 2. X minus 1 plus 2 is plus 1 is equal to 2. So x is equal to 2 minus 1. The value of x is 1. So now we find the values of y, z and x also. Therefore, the solutions are, okay, the solutions are x is equal to 1, y is equal to 1 and z is equal to 1. In the particular question, all the values become 1, but the values are different. Now you see exactly the value of x is only one value, y is only one value and z is only one value. So the system has unique solution. So it is the first case. Suppose both the rank is equal to 3, the system is consistent and the system has unique solution. And also to find the unique solution in the previous one. Now you see x, y and z all have exactly one value.